Okay, today marks the first day of enrichment for science, and today we're actually going to go over the basics of atoms. You learned about atoms and atomic structure earlier in the year, but we are going to review over it today. So what you see in front of me right now is basically just some basic parts of an atom. We have our nucleus in the center and our electron cloud around it. So the first main part of an atom is the center, and this is called the nucleus. The nucleus contains protons and neutrons here. So you can see that I've labeled my protons, which are pink, and my neutrons, which are blue. The other third subatomic particle within an atom, we call those electrons. Electrons are very, very small, and they're found orbiting the nucleus. Now, these three subatomic particles have certain charges. Protons are positive. As you can see here, you characterize them with this positive sign. And neutrons have no charge whatsoever. And they're just neutrons, their main reason to exist is basically to give mass to an atom. The charge of an electron is negative, and they basically are the opposite of protons, but opposites attract, and as many protons as you have in an atom, you should have that same number of electrons. Now, our next thing that we're going to talk about is the mass of these subatomic particles. So, the mass of one proton or neutron, they're about the same. Now, there are a few decimals off of each other, but in science, we say that they're about the same mass. So, really, when you kind of think about the mass of a proton or neutron in terms of grams, it's a very, very small number, and this is a lot of zeros, and that's not really what we want in science. It's not really a good unit to measure in a proton or a neutron. And if we were to use scientific notation, you could do this. But scientists have come up with a really easy way of measuring the mass of a proton or a neutron, and that's what we call 1 AMU. And AMU stands for atomic mass unit. Now, 1 AMU, that's really, really small. It's not even 1 gram. And if we talk about the mass of an electron, we're even getting smaller. The mass of an electron is 0.000549 AMU. So you can clearly see that protons and neutrons are much more larger than electrons. And electrons, they don't really have anything to do with the mass of an atom. They're just orbiting really, really fast around the nucleus. Now, the protons and the neutrons, they do have a lot of significance when you look at a periodic table. For instance, here's an example of helium. The proton number here gives us the atomic number. But when you're talking about that decimal number on the bottom, for example, 4.0026, how we got that number was adding the number of protons, number of neutrons for this element of helium. Now, you've already gone over this with your teachers this year, but as a review, which would really help you on the back of your activity today, A, atomic number. Now I put that right next to the 2 here because that is the atomic number of helium. Now the atomic number always equals the proton number. And that's very important to remember. The proton number always identifies an element. Even if the electron number is different sometimes because of reactivity, proton number will always identify an element. Now normally when we're talking about a neutral atom, the number of protons always equal the number of electrons. So as you can see here, we have the word ape, and that's very easy to remember. Now that bottom number, like I said earlier, is our mass number, 4.0026. Now normally you're going to round that number to a whole number, which is going to be just 4. So in this case, we're just going to ignore the decimal there, and we're just going to really think about the number 4 there. So the mass number, 4, minus the atomic number. Now the atomic number in this example is 2. So 4 minus 2 equals our neutron number. So for helium, helium has 4 as its mass number, subtract the atomic number, that's going to give us the number of neutrons, which is 2. Okay, so earlier we talked about the backside of your worksheet when referencing 8-man. Well, what I want to talk to you about right now is how to correctly make a Bohr model. So if you notice here, this Bohr model is not really the best model of an atom, but I really would like you to understand the rules of electron configuration for Bohr models. So here we have our nucleus, but surrounding our nucleus is our first energy level. Our first energy level is going to contain 2 electrons. Now, if these 2 electrons were full, we'd have to go to the next energy level. Now, on the next energy level can hold up to 8 electrons. If you have less than 8 electrons, you cannot go to the next energy level. You can only go to the third energy level if you've filled up all of those 8. So if you go to this third energy level, again, you have to have up to 8. Now for rules, for bigger atoms, it gets a little bit confusing, so we're really only going to stick to these rules here. I have an edited periodic table here, very much similar and different from the periodic table that you have in front of you as well. So if you notice, I have group 1, group 2, and then I have all the transition metals taken out. Then we have groups 13 through 18. Now remember, I've kind of put my numbers here for 13, 14, 15, 16, 17, and 18 a little different so that you remember that black number tells us the number of valence electrons. So do group 1 and group 2, okay? So our first atom that we're going to practice building today is hydrogen. Now hydrogen, if you look here, has 1 as its atomic number. And if you look here is also, just as a review, the mass number is 1.008. Now, to make this Bohr model of hydrogen, you'd have to make your first energy level here, and since we have 1 as the atomic number, we're just going to make 1 electron, just to equal that 1 proton in the nucleus. Now, when we make Bohr models, we're really not going to focus on neutrons in the nucleus, just because we're really focusing on correctly placing those electrons in the right energy levels. So that was pretty easy for hydrogen. The second element that we're going to focus on today is lithium. Lithium is also in group 1. Lithium has 3 as its atomic number, and if you want to practice rounding, its mass number is 6.941, and if we round that, that comes out to being just 7. But again, we're just going to focus on the atomic number for right now. So lithium has 3 as its atomic number, so that means we have 3 protons in the nucleus. And you can see here that I have went ahead and filled up our first energy level here with 2 electrons. Now that does not equal 3 protons. According to 8-man, A equals P equals E, my protons have to equal my electrons. So I'm forced to make another energy level. Now on this other energy level here, you notice that I've only shaded in 1 extra electron in that second energy level. Kind of ignore the other electrons that I haven't filled in. So we have 1, 2, 3 electrons, 3 protons, 3 is the atomic number. That's good. The last element that we're going to focus on today is sodium. Sodium has the atomic number of 11 and its mass number of 22.990. And if you were to try to round that would be about 23. So the atomic number is 11, so that means that its proton number is 11. And remember that plus sign represents the positive charge of that those protons. So we have 11 in our nucleus, and you can see that I have filled up that first energy level again with 2 electrons. So that's going to force me to go to the next energy level here. Now I've filled up my second energy level with 8 electrons. So if you add this up, that gives me 8 electrons plus 2 electrons gives me a total of 10. Well, I need 1 more. So I'm forced to make 1 more energy level. So here is my third and final energy level. Notice that I have not fully filled it up, but I've just put 1 valence electron there. So if I count them, 1 plus 8 plus 2 will give me 11. So that's correct. Now, if you notice any similarities with these Bohr models, 1 electron in the outer shell, 1 electron in the outer shell, 1 electron in the outer shell. We call these electrons in the outer shell valence electrons, and they help us realize what group they're in and what chemical characteristics, chemical reactivity characteristics they have. So if they all have 1 valence electron, they're going to be found in group 1 here. Same as if I was talking about nitrogen. Nitrogen in group 15 will have 5 valence electrons. If I was talking about fluorine, F in group 17, it's going to have 7 valence electrons. So I hope this helps with your reactivity, valence electrons, and atomic structure.